Today in class, we talked about the different types of real numbers that there are and the different classifications that they can have. We talked about natural numbers, and we said how natural numbers are the set of counting numbers. And we said, well, we count 1, 2, 3, 4, 5, so on and so forth. So if a number falls into that category, 1, 2, 3, 4, 5, and so on, then it is considered a natural number. Whole numbers are numbers that start at 0 and then continue on. So the whole numbers are 0, 1, 2, 3, 4, 5, so on and so forth. Integers. An integer are all the positive and negative numbers that usually would fall within a number line. So all the way to negative infinity, coming up on -3, -2, -1, 0, 1, 2, and 3. So what our goal is going to be today is to classify which subgroups the number that I give you is on. Okay, so if I throw out a number and I say -15, and I say, is -15 a natural number? What you need to think of is, in your mind, does -15 fall within the group 1, 2, 3, 4, and so on and so forth? Well, no. -15 is not a natural number. Would it be a whole number, -15? Well, no, because the whole numbers start at 0 and they go 1, 2, 3, 4, 5. However, -15 would be an integer because -15 is a number that is on a number line, and if we continue to count in the negative direction, we would hit -15. Rational numbers are numbers that can be written as fractions. They are terminating decimals, repeating decimals, and perfect squares. So because 1/2 is a fraction, it is considered rational. 4.6 with a bar above it, well, that bar above it means that it repeats, and since this decimal repeats, it is also rational. 6.73 is a decimal that terminates. Terminating means that it ends or that it has a stop to it. This number does not go on forever, it stops. And then the square root of 49, which when simplified actually gives us 9. Okay, 9 is also a rational number. Whereas irrational numbers are numbers that cannot be written as fractions, non-terminating decimals, non-repeating decimals, and non-perfect squares. So an example of an irrational number would be 3.64213 ... that has no pattern to it, no rhythm to it, no repeating. However, it does go on forever. Pi, which is 3.1415 continuing on forever, is irrational because it also doesn't have a repeating pattern. And then lastly, the square root of 126, when I put it into my calculator, the square root of 126, I get 11.22497216. It goes on to the edge of my calculator, which means it goes on forever, and there is no repeating, which makes it irrational.